5 or 6.
Right.
But I was just wondering about like exactly if they were the same thing or different.
So as far as I know, as far as I can remember, let me go back to this. You can't see that, can you?
Because that one with the picture of the child with the tonsils and all that, I was trying to figure out like exactly.
Right. So there we go.
Yeah, slide number 6 at 26. I was looking at trying to figure out like
This one.
Yeah.
So as far as I know, what they call your tonsils are these palatine tonsils, and then your adenoids, I think, are these lingual tonsils, which are further down. As far as I know, that's the terminology.
Yeah, well, it says adenoids are a patch of tissue that is high up in the throat, just behind the nose.
Oh, okay. So maybe they are another patch of tissue that's here then, back here.
Yeah, they're along with the tonsils are part of the lymphatic system. The lymphatic system clears away infection to keep the body balanced, all that. But
Right.
the adenoid is a clump of tissue located behind the nasal cavity above the roof of the mouth. Tonsils and adenoids fight infection. So that's why I was wondering exactly where those would be.
So I guess maybe they're the pharyngeal tonsils. I was thinking they were the lingual ones, but maybe they're these. So it's the same thing, whether you call them tonsils or adenoids. They're just patches of tissue. Yeah.
Okay.
So you can imagine that if this was swollen and if this was swollen, your airway would be really tight, you know?
All right. Yeah, I was just curious if it was all the same.
Absolutely. All right. So we talked about returning fluid. We talked about the lymph nodes. And now we have to get to talking about the body's defenses, right? So talking about the immune system happens in the lymphatic system, but the immune system is really part of, the respiratory, the circulatory, the skin, right? All these different systems of your body. There are 2 general categories of body defenses, and they work together to provide the best resistance you can, the best defense that you can mount. And we have these innate immune defenses and these adaptive immune defenses. As I said, innate are things that you're born with. They are non-specific, right? This has to do with your genetics. A lot of times what your genetics are, what you've inherited from your parents. The adaptive immunity is not present at birth. It's something that you develop as time goes on. Your immune system develops, and your T cells and B cells can become activated by different antigens and respond to those antigens. Right? So we'll talk about the innate defenses first, the things you're born with, things that are non-specific. And they include all of these things. They don't distinguish between threats, right? So they just see something that does not look right, whether it's a foreign, like a bacteria or a virus, or a cell that's not, that looks sick, that looks like it's infected, right? It's something that doesn't look right, and that will trigger some of these innate defenses. They include all of these things: physical barriers, phagocytes, immune surveillance, interferons, complement, inflammation, fever. We're going to talk about a little of those things, a few of those things. So physical barriers are exactly what you think of. They are trying to keep microorganisms out. The biggest one that we have, obviously, is our skin, right? Our skin's role is to try to keep things out. It acts as a barrier. We do have glands that secrete things to the surface of our skin, and some of those secretions have enzymes in them, and those enzymes can actually break down certain microorganisms. Along with your skin, your mucous membrane is a barrier. So lining your digestive and respiratory tracts is a mucous membrane. It is coated with mucus, and it has its own special enzymes, antibodies, and an acidic pH. So again, you're hoping to trap these microorganisms in those mucous membranes so that they don't get further into your body. Sometimes things get into your body, And one of your body's defenses are phagocytes. So there are a number of white blood cells that are non-specific, right, that we talked about, that just chew up things that don't belong. Neutrophils are the most common. And so macrophages, or I'm sorry, neutrophils are kind of your body's first line of defense inside the body. So once things breach that barrier and get into your body, one of your first lines of defense are neutrophils. Neutrophils can actually leave your bloodstream and get into an infected tissue, and they could phagocytize, right? That means they can chew things up like Pac-Man, right? They are attracted or repelled by certain chemicals. So sometimes there are other cells that'll put out these chemical signals that attract neutrophils, right? And we'll see that some of the other cells in the immune system will do that. So that if one type of cell is attacking a pathogen, it'll put out a signal calling other types of white blood cells to the area to help fight that pathogen. There are different macrophages. So one of the types of white blood cells are called monocytes, one of the 5 types. Monocytes get out of the bloodstream and they get into a lot of your tissues. You have them in your respiratory system, you have them in your liver, you have them in your nervous system, you have them in your skin, and they become what are called macrophages. Macrophage, macro means large, phage means eating. So they are large eating cells, very similar to neutrophils, but they're bigger, and they are in your tissues, rubbing around your tissue, chewing up things that don't belong. There's also immune surveillance. There are natural killer cells. And natural killer cells could recognize the surface of your own cells versus the surface of cells that are not your own, right? The surface of every cell has markers on the outside of it. And natural killer cells, NK cells, recognize those marks on the outside of the cell. So they can recognize which ones are yours, which ones are not yours. And they will kill off the ones that are not yours. So they recognize foreign antigens like bacteria, viruses, or cancer cells. They respond very rapidly. And what they do is they attach to the cell and they secrete something called a perforin, which perforates the cell. It makes little holes in the cell. And what happens is if you punch little holes in the cell, water rushes in and that cell lyses open. There are interferons. These are specific chemical messengers that are released by activated lymphocytes, macrophages, and tissue cells infected with viruses. They're the normal cell response to interferons is that they produce antiviral proteins. So these interfere with viral replication. So if a macrophage, if a non-specific white blood cell chews up something with a virus, it will put out this chemical signal. If a lymphocyte gets activated, which we haven't talked about yet, gets activated and is fighting something with a virus, it will put out this signal, these cytokines. Even sometimes when a tissue cell is infected with a virus, the tissue cell itself can put out these chemical signals, these cytokines. What these cytokines do is they talk to cells nearby, and the cells nearby produce interferons. And the cells that produce these interferons are producing antiviral proteins. They're producing viral proteins that interfere with virus replication, right? So basically, one cell is calling all the other cells nearby saying, okay, you know, there's a virus infecting the immune system and infecting this person's body. We need to fight against that virus. So, you know, this is one of the first times that you're seeing, we're talking about these interferons are part of the innate immune system, and they are, right? Macrophages can secrete interferons or secrete cytokines, but also activated lymphocytes, which are part of your adaptive immunity, can secrete cytokines, which will produce interferons as well. Okay, so you're getting this crosstalk between adaptive and innate immunity. The complement system is really cool. The complement system is kind of these proteins that are floating around in your blood, and when they get activated, they bind together And what they do is they, first of all, they attract other white blood cells to help with phagocytosis. But they basically form an arrow and they start poking holes in the plasma membrane of whatever bacteria cell is present. And again, that's going to cause water to rush into the bacteria cell and the cell will explode. This also promotes inflammation, which we'll see inflammation is there to try to slow down any viral infection, any pathogen infection. Okay, so inflammation is the localized tissue response to injury. It produces swelling, redness, heat, and pain. And that's because your white blood cells, when they're injured, they're going to release histamine and heparin. Right? It does two things. Histamine dilates all your blood vessels and makes them bigger. And heparin thins your blood. And what that's doing is you are shuttling a bunch of blood to the damaged tissue to try to repair it, to try to help aid the repair of that injury. You're mobilizing all your defenses. You're getting as many of those cells to that area as quickly as you can, right? That's why the area gets swollen and red and warm, because you're rushing blood to that area. Fever is another innate response. It's another innate immunity. Fever is produced when you have these cells that produce pyrogens, and pyrogens actually increase your body temperature. Now think about it. If bacteria infects your body, its optimal conditions are body temperature, 37 degrees is body temperature. And if you raise that body temperature, it's going to be less than optimal conditions for the bacteria. So what this does is it slows down the ability of the bacteria to grow. Okay, the bacteria are not as happy with it being too warm. And it increases your body's own metabolism. Right? One thing that always increases your metabolism, if you know anybody with a high metabolism, or if you have a high metabolism, you're warm all the time. Right? It increases your body temperature, and increasing your body temperature increases your metabolism. And so it's increasing your body's ability to fight off this infection, and it's slowing down the actual pathogen's ability to reproduce. It's not killing anything, right? But it's just helping your body. So that's helping you mobilize all these other things, the macrophages, the neutrophils, helping get the complement system set up. All these things are working in conjunction to try to do their best at defending your body. Now, a mild fever is beneficial, right? If you are running a mild fever or your child is running a low fever, that's a good thing. That means their body's fighting off whatever's making them sick. If you get a high fever, something like 104 degrees, then it can get to be bad, right? Then it can actually start to damage some of your system. But if you have a fever of 101, that's actually a good sign. That's a sign that your body is fighting something off. So here's a nice summary of the body's innate defenses. In the top panel here are physical barriers. So this is your skin. Phagocytosis, these are the types of white blood cells that can undergo phagocytosis. Immune surveillance by natural killer cells. Interferons being released by cells that are infected. Complement, punching holes in a bacteria cell to kill it. Inflammation, which is increasing things like blood flow and activating macrophages. And fever, raising your body temperature to kind of increase a lot of these other things. So when we're looking at immunity as a whole, those are the innate, the non-specific immunities. Right? But we have all this adaptive immunity as well. And adaptive immunity is not present at birth, right? But you acquire immunity to a specific antigen. It's very specific, and there's memory associated with it. Body will remember that and have an army ready to go the next time you see that pathogen. There is active and passive immunity. Active immunity develops in response to being exposed to something. So, if you got chicken pox when you were a kid, you were exposed to chickenpox. Your body made a bunch of T cells to fight off the chickenpox virus. If you get exposed to it again, you'll already have an army ready to go. And so that's active immunity. You've been exposed to that thing. Passive immunity is produced by the transfer of antibodies from another source. So oftentimes, if people are on their deathbed, right, people are really sick, oftentimes they're given antibodies from a healthy individual to help stave off an infection, right? So that would be artificially acquired passive immunity. You're not activating that person's immune system. You're just giving them antibodies to keep them from getting sick. Now, you'd have to do that every couple of days. Another example of passive immunity is the transfer of antibodies from the mother to a newborn infant when she's breastfeeding, right? That's natural. The newborn infant doesn't have its own immunity yet. It doesn't have this acquired immunity yet, but it's going to get those antibodies from its mother's breast milk and have some immunity based on her immunity. Active immunity is where you've actually been exposed to an antigen. It can occur naturally, like when you get the chickenpox, or it can occur artificially, like a vaccine. So what they do when they inject you with the vaccine is they make that vaccine really close to what the actual virus is, right? Usually it's just a form of the virus that won't cause any symptoms. And what it does is it activates your immune system. So it gets that army of cells ready to go so that the next time you see that particular pathogen, you're going to be immune against it. You're going to fight it very quickly and very strongly. Okay. Make sure you know the difference between active and passive immunity and between naturally acquired and artificially acquired. I'm going to stop there. What we will do on Friday is we'll do a lecture about cell-mediated immunity versus antibody-mediated immunity. What are these T cells and B cells doing, right? And what are the differences between them? We'll save that for Friday. That's the last part of this chapter. And then make sure you have, any questions that you have for me. Make sure you ask those on Friday. We will we'll have a test. I'll post the test on Friday, and it will be on 4 chapters. It will be on the blood, the heart, the cardiovascular system, and the lymphatic system. So you can see here that I have created, right? Well, there was a cardiovascular system quiz due yesterday, which hopefully you guys took. There is a lymphatic system quiz due on Sunday the 5th. And then on Wednesday, the 8th, so a week from tomorrow, is your cardiovascular system homework, your lymphatic system homework, and your lymphatic system lab. They're all due next Wednesday, right? And that lab is, there's not a lab in the box that goes along with the system. So we're going to do that lab. It's different. I made sure that it was different than the muscle lab that I did earlier this semester. So it's different than that. It shouldn't take nearly as long. It should be more understandable. So make sure you are looking at those as well. What I'll do tonight and tomorrow is I'll go in and I'll update your grades based on Pearson and based on any lab work that you guys have done. So some of the pictures, like the pictures of the heart and stuff like that, I'll make sure I do that, and the pictures of the blood typing, right? And then we're almost done, right? Then we just go through digestive and respiratory, and urinary system and reproductive system, and that's the end of the semester. So we'll do digestive and respiratory. There's a good respiratory lab that has to do with breathing, with how much air you're exhaling, basically. And for the digestive system, what we'll do in here somewhere is we'll dissect the pig. You can see a lot of the digestive organs in there, as well as cardiovascular and urinary and a lot of the other organs. So we'll do that in here somewhere. And those will be our last couple of labs.
When's the last day of class then?
That's a good question. Let's see what I put on the syllabus. So your final exam will be posted on December 20th. So December 13th will be the last week of classes. So that's going to be, let's see, December 13th, we'll have class on the 15th and maybe the 17th. Right? That week, the 13th is the Monday. So that week we'll do probably the 15th and the 17th. So just a couple more weeks really, and then I'll post the final exam after that. So I would say 12/17. Let's plan on that being the last Friday. Okay. I'm sorry, Peter, I cut you off there.
So that will be exam 6?
Yes, exam 6. So exam 5, which I'll post next week, will be on the cardiovascular system and the lymphatic system, right? And then exam 6 will be on digestion and respiratory.
And exam 6 is the final exam, right?
Right.
Okay.
So it'll be digestive respiratory. Oh, no. Sorry. You'll have exam 6 on digestion and respiratory. Then the final exam will just be on urinary and reproductive. You'll have 7 exams, okay. But the final won't be cumulative.
Okay. I was trying to figure things out because the 20th I have to be in jury.
I don't know why I did that. So. Sorry.
So yeah,
so the final exam will cover all the topics?
No, it won't. Okay. So exam 5 is the one next week. Exam 6 will just be digestive and respiratory. Your final exam will be exam 7, and that will just be urinary and reproductive.
Okay.
So it won't cover the whole semester.
And that one will be due 12/20.
Right. Well, I'm not sure if it'll be due 12/20. It'll be somewhere around there.
Okay.
It'll be due that week sometime.
All right. I was just trying to figure stuff out because that 12/20 out, I'm going to be in jury duty and.
Oh. So it'll probably Friday the 17th will be our last day of classes, which means I'll probably post the exam on the 17th. And you'll have till like the 22nd to do it or something like that. You know what I mean?
Yeah, I just want to make sure I have time to do it.
Yeah, I'll give you guys time to do it.
Okay. I have to be, I plan all this out when I see the dates when I'm doing them, so.
Right, absolutely. Absolutely.
All right. Okay, then.
All right.
Hey, you guys have a good day. I have
Thanks.
a 180-pound dog that needs to go out.
All right. Have a good day.
Bye, guys.
Thank you.